Friends, very good morning. Myself, Dr. M.A. Channaya, and in today's video, we are going to learn how to draw the development of the lateral surface of a rectangular pyramid, which is cut by two section planes. So basically, you have to go through the problem first, write down its top and front view for the given condition. The question reads like this: a rectangular pyramid of base 20 mm by 30 and height 60 mm resting on HP on its base means that rectangle on HP, such that one of the shorter edge of the base is normal to VP. So this shorter edge, say AB, is perpendicular to VP. So for this position, friends, you get the top view, a rectangle with the center joint to all the corners, and front view is going to be a triangle. So friends, let us write down the top and front views of the pyramid. So this is the top view, a rectangle, and I am going to join these diagonals to obtain the center of the pyramid, or this O. We will mark this as A, B, C, D, A, B, C and D. This A, B, C, D represents the base of the pyramid. I project the points from there and get A dash, B dash, C dash, D dash on XY, representing the base of the solid. And friends, from here I am going to write a vertical line and show on that vertical line the height of the pyramid. The height of the pyramid is given to be 60 mm. This is O dash, and I just draw a line here and mark the distance. The height of the pyramid as 60 mm. We are going to join this O dash to A dash, B dash, O dash to C dash, D dash, and this is how the pyramid looks in the front view, and also in the top view it's going to be a rectangle with this corners joined to O. So in the top view, OA, OB, OC, etc. represent the top view of the slant edges, and here these are the two triangular faces, OCD and OAB, that I will show you. So when it is resting like this is one triangle on the left end, this OCD, and the right side you have got OCD, left side you have got this OAB. Now we have written or drawn the front and top views of the pyramid. It is cut by two section planes, both normal to VP. Friends, whenever any section plane is normal to VP, it is seen as a line indifferent. And this object is being cut by two section planes, out of which one of them is horizontal. That is, it is parallel to XY in the front view, and the other is inclined at an angle of what angle 60 degrees to horizontal, and they intersect at the midpoint of the axis. Where is the midpoint, friends? Midpoint is at the mid height. From here you have to take, from O1 dash you will take 30 millimeter, that is midpoint of this axis, O dash, O1 dash. And here we are going to write two section planes. One of them is horizontal. Say this section plane is horizontal. I'll call it as 1 1. 1 1 is one of the section planes which is horizontal, and the other is inclined at an angle of 60 degrees to the horizontal. So this angle is 60 degrees, and both of them intersect at the midpoint of the axis. Friends, the horizontal section plane is cutting O dash A dash and O dash B dash, and this section plane 2 2 which is inclined, that is S2 S2 I will call. This is S1 S1, section plane S1 S1 is this one. So friends, we are going to retain the lower part of this pyramid to draw the development. So this is the portion that is left over for the purpose of developing this. So we will call this part as P. Friends, basically the section plane S1 S1 is cutting OA and OB, so you have 2 points here. Section plane S2 is cutting OC and OD here, you get 2 points. And they are meeting at the midpoint of this side AC, AD and BC. So friends, here when we start drawing the development, we need to have the true length of the slant edges. Here if you observe the front view, none of these edges, OA to OD, are true in length because none of the top views, either OA, OB, OC or OD, is parallel to VP. Hence, I draw a horizontal line through this O and take O as center, OC as radius, I strike an arc. To make that line parallel to VP, I produce it upwards. So this point C, I will call this as C1 dash. And hence this line, I am showing by dotted line, will give you true length. So true length is O dash C1 dash. So taking that as a measurement, let us start drawing the development. So friends, I mark a line here and true length, that is O dash C1 dash. I will say true length here and this is O, the vertex. Taking O as center, this length as radius, I am going to draw an arc through this. So I am going to draw some arc there. And on this arc, I am going to step off these distances. So this is given to be 30 mm and the longer edge is given to be 30. One is 20, other is 30. So in the development, if you observe, none of these slant edges are totally removed from the solid, and hence you can start the development either from OA or OB or OC or OD. Say I am starting from OA. After A comes B, that's AB is 20. I will take 20, again 30, again 20, and again 30. So friends, these distances are 20 mm, 30, 20, and 30. So this point is going to be B, this is C, point D, and point E. So let us join all these by straight lines. This is how I join, this is also true length. So OE is not E sub E, this is A again, because starting and end point should be same. Let's also join this by straight line, the base edges, by thin lines to start with. These are all the base edges we have got. Friends, let us consider section plane 1 and see where all it is cutting. Section plane 1, which is horizontal, is cutting OA and OB at this point. OA dash, A dash, O dash, B dash are not true length. Hence, I am going to shift it to the true length line, to the last line, and make this measurement or mark this measurement on OA and OB. OA, OA and OB. This is the distance I have marked. Then comes this section plane 2 is cutting OC and OD here. This is also again not true length. I am going to shift it to the right, take that measurement on OC and OD. OC and OD will be of that thing. Then friends, the two slant edges are cut here, these two are cut here, but these two intersect at the midpoint of the axis. So friends, here midpoint, I have to show a line in between AD and a line between BC, and there we have to mark this point of intersection. So I have to take AD and BC. AD is here, I'll write a line at a perpendicular bisector, and then we have got BC, another line here through this. So on these two lines, we should take a measurement equal to this much. That is same as the distance on OA and OB. The distance on OA, same, and distance on OB. OA and That is, this distance we take. So friends, we have got so many points, let them number them. 1, this is 2, this is 3, 4, 5, 6 and 1 again, because 1 is on OA. Let's join them by straight line. So 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6 and this distance. So the portion on OA, this much is retained. This you have to show by full line. Again on same distance is retained on this OB. This has to be by full line. All these base edges are to be shown by full line like this. So friends, again here on OC and OD, this part is retained, and this is how friends you get the development of this part which is below the section planes and on this XY. So I will call this as development of P, the lateral surface of the lower part of the pyramid. And friends, you can see here in the development, all the base edges are intact. AB, BC, CD and DA. And on OA and OB, this length is removed to two sides, OA, OB. So this will not exist. Show by thin line, this by thin line, this by thin line, and also this by thin line. And only this portion along with the base edges will give you the development. Friends, if you like this video, please share this information with all your friends. And I thank you very much for watching my YouTube video.